Chapter 3.4, Quick Review, Problems 1 through 10. Section 3.4 in our book has to do with exponential, logistic, and logarithmic functions. So this set of exercises is a warm-up for that. In exercise 1 through 4, evaluate the expression without using a calculator. And in this case, we have the log of 10 to the second power, or 10 squared. And so for this, we should remember that LOG stands for log base 10, sometimes called the common logarithm. So I'm just going to rewrite this as base 10. And so we bring over 10 squared, 10 to the second power. And so a logarithm, this is the answer to the question, what power do we have to raise 10 to get 10 squared? What power do we have to raise the base of the logarithm to get what we're taking the logarithm of, in this case 10 squared? And so I like to rewrite this as a logarithm equation. So I'll write this as log base 10 of 10 squared is equal to x. And so rewriting this equation now as an exponential equation, we will rewrite this as 10 to the power of x equals 10 to the power of 2, or 10 squared. Well, in this case, we see that x and 2 are in the same place on each side, everything else being equal, so we know we should be comfortable that x is equal to 2. So it really makes sense, doesn't it? Because what power do we need to raise 10 to equal 10 squared? Well, that'd be to the second power. Next on our problem, 3. ln e to the negative 2 power. Well, ln is log base e. And e is Euler's number. So we'll rewrite this as log base e of e to the negative 2 power. And e is Euler's number. Leonhard Euler, the great Swiss mathematician, in whose honor this number was made. And e is approximately equal to number 2.718, and so on, an irrational number. Has very unique properties and will really help in the world of finance and in calculus. And so we're going to write this log base e of e to the negative 2 power as equal to x. So our base of our logarithm, e to the power of what, is going to be equal to e to the negative 2 power. Well, here x and negative 2 are both exponents of e, so x is going to be equal to, therefore, negative 2. The even number problems here, 2 and 4, should be pretty easy. Next on our problem, in exercise 5 through 10, simplify the expression. So we're going to be kind of reviewing our rules of exponents. And there are 3 major rules of exponents. There's the product of powers, and that rule is that x to the a times x to the power b is going to be equal to x to the power of a plus b. Next, there is the power of a power of powers, and that rule is x to the power of a, and that expression raised to the power of b equals x to the power of ab. So we're talking about multiplying in this case. And lastly, we have what we call the quotient of powers. So there's the rule of negative exponents. I believe quotient of powers and that is, I'm going to write this to the right, x to the power of a over x to the power of b equals x to the power of a minus b. There's the rule of negative exponents. I'm just going to write this down here. Negative exponents. And that rule is 1 over x to the negative a power is equal to x to the power of a. Or we can take this as x to the negative b power is equal to 1 over x to the power of b. And then we have the zero power rule, which is x to the power of 0 equals 1. So those are the 5 major rules of exponents. And here we're going to take this one. For this one, we're going to take the rule of quotient of powers. So we can rewrite this expression as x to the power of 5 on the top here. We have x squared at the bottom minus 2 times y to the power of negative 2 minus negative 4. So those would be x to the third power times y to the, well, we have negative 2 minus negative 4. Well, negative 2 minus negative 4 is squared. And so this would be our answer to problem number 5. Next odd number problem, which is 7. In exercise 5 through 10, simplify the expression. So what we're going to use is the power of power and take 6 times 1/2 and negative 2 times 1/2. First, I'll say that something to the 1/2 power is equal to the square root of that thing. So what that tells you is that we can't have anything inside the parentheses here that is less than 0, because we can't take the square root of a negative number. Because we can't multiply two numbers together and make that two of the same numbers together and have the result be a negative number. So anyway, let's distribute here. And we have 6 times 1/2. So we'll put x to the 6 times 1/2 and times y to the negative 2 times 1/2. And those would be x to the third power. And then we would have y to the y to the negative 1 power. And that's going to be x cubed over y. And what happens is, the way the book handles this is, in order to assure that inside the parentheses here is not negative, they make this an absolute value of x to the third power over absolute value of y. And that's just one way of looking at it. I will box in my original answer like this. So as we're aware of what's going on here. Next, problem 9. We're going to distribute, as we did earlier. We have in the numerator u to the power of 1/2 times 2. I'll just write out 1/2 times 2 times v to the power of -4 times 1/2 over all this to the 1/3 power. So what we're going to have in the denominator, 27 to the 1/3 power equals the cube root of 27. And what that means is, what number do you multiply by itself 3 times to equal 27? And that's going to be 3. So we rewrite the denominator. 27 to the 1/3 power is 3. And then u to the 6th times 1/3, we're going to say times u to the 6th times 1/3 times v to the -6 times 1 fraction 1/3. And so coming down here, we say u to the 1/2 times 2, that's going to be u to the 1 power, times v to the -4 times 1/2 will be to the -2 power. In the denominator we have 3, and 6 times 1/3, we're going to have u to the 2nd power times, and we have v to the -6 times 1/3. Well, 1/3 of 6 is going to be -2, or v to the -2 rather, times v to the -2 power. And so we can cancel v to the -2 power with v to the -2 power, and we're left with u over 3u squared. And we're going to have u to the 1 power minus u to the 2 power. I mean, the exponent we subtract, that's going to be quotient of powers. So we're going to have u to the -1 power. So what we have here is 1 over 3u. And because of the constriction above, the book asks us to make sure that we have things right by taking this u, the absolute value of u, which would be important, but I'm just going to box in this answer is correct anyway. These are the odd number problems in this exercise set, including a review of the basic 5 rules of the rules of exponents. Good luck to you on your even number problems as a demonstration of learning, and thank you for viewing.